Hello, in this lecture we'll find out the area of the green shape in three different methods. In the drawing we have rectangle ABCD. We know that AE equals to ED. We also know that BE equals to 7 units and BF equals to 9 units. Angle ABE equals to theta and angle EBF also equals to theta, and we want to find out the area of this green shape. Okay, so we'll start with the first method. In the first method we will do a construction. We will extend side CD and side BE until they intersect with each other. Okay, so we will extend this side BE, and we will also extend side CD until it intersects with the extended BE, and we will define the intersection point between the extended BE and the extended CD as point P. This point is defined as point P, and we actually know that the CD is one side of rectangle ABCD, therefore it is absolutely a straight line. And we extended the straight line CD by a straight line. So actually PC will be still a straight line because we extended the straight line CD by a straight line. Okay, so we can write down that PC is a straight line, PC is a straight line, and we also know that all the sides, all the angles inside the rectangle are right angles, so this angle is a right angle, that is to say it equals to 90 degrees, and this angle it is also a right angle equals to 90 degrees, and this angle it is also a right angle because it is one out of four angles of rectangle ABCD, therefore it is a right angle. And we also have rule number 1. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. I'll write it down. The sum of the angles on one side of a straight line is equal to 180 degrees. So I read rule number 1 again. according to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. So actually we know that PC is a straight line, and if we focus on this side of the straight line PC at point D, the sum of its angles must be equal to 180 degrees. So we define angle PDE, this angle is angle X, and according to rule number 1, if we focus on this side of the straight line PC at point D, then the sum of the angles on the straight line PC must be equal to 180 degrees. That is to say, angle X plus 90 degrees must be equal to 180 degrees according to rule number 1. So angle X plus the angle that equals to 90 degrees must be equal to 180 degrees according to rule number 1. Okay, so here we will subtract 90 degrees from this equation, and we will get that X equals to 180 degrees minus 90 degrees, it equals to 90 degrees. So we found out that angle X equals to 90 degrees. So we can write here that angle X, we can substitute angle X by a right angle because it equals to 90 degrees. And we also know that the opposite sides of a rectangle are parallel to each other. That is to say, AB is parallel to DC, but we know that PC is one straight line, and therefore, because of the fact that PC is one straight line, then if AB is parallel to DC, then AB will be also parallel to PC. That is actually the same straight line. Okay, AB must be also parallel to PC because of the fact that AB is parallel to DC. PC, it is one big straight line, the DC is part of it. So if AB is parallel to the straight line DC, AB will be also parallel to the straight line PC, that is the extended DC. Okay, it is the same straight line. So we know that AB is parallel to PC, AB is parallel to PC, and those two angles are defined as alternating angles, and we have the rule number 2. According to rule number 2, alternating angles between parallel lines are equal to each other. I'll write it down. According to rule number 2, alternating angles between parallel lines are equal to each other. So I'll repeat on rule number 2 again. According to rule number 2, alternating angles between parallel lines are equal to each other. So actually, those two angles, that is to say angle ABE and angle DPE, those two angles are defined as alternating angles, and they are located between the parallel lines AB and PC. Therefore, they are equal to each other according to rule number 2. So we can write down that this angle ABE, is equal to this angle DPE. According to rule number 2, because of the fact that those two alternating angles are located between the parallel lines AB and PC, therefore they are equal to each other. Repeat again. Angle ABE equals to angle DPE according to rule number 2. But we know that angle ABE, this angle, equals to theta according to what is given us in the question. We know that angle ABE equals to theta. It is given us in the question. And from this equality, from this equation, this equality, we will conclude that angle DPE also equals to theta. Okay, angle DPE also equals to theta. So we can write here that angle DPE equals to theta, according to rule number 2. And in the next step, we will prove that those two right triangles can go into each other. Okay, so we will focus on the right triangle ABE, this right green triangle ABE. And the right green triangle and the right triangle PED. And we will prove that those two right triangles can go into each other. First of all, we just right now proved that those two angles are equal to each other. They are both equal to theta. So we can write down that this angle ABE with the green triangle is equal to this angle DPE, this angle, and they are both equal to theta according to what is given us in the question. So we found out that angle ABE equals to angle DPE equals to theta, and we also know that those two angles, they are both right angles, therefore they are equal to each other. That is to say, angle BAE, integrate angle, is equal to angle PDE in this triangle, and they are both equal to 90 degrees. They are right angles. So angle BAE equals to angle PDE equals to 90 degrees, and those two angles, they are vertex angles, and therefore they are equal to each other according to the rule that vertex angles are equal to each other. So this angle, angle AEB of the great triangle, is equal to this angle, angle PED, and they are equal to each other according to the rule that vertex angles are equal to each other. I will repeat again. Angle AEB equals to angle PED, and they are equal to each other according to the rule that vertex angles are equal to each other. And we also know it is given us in the question that AE equals to ED. AE equals to ED, it is given us the question. I will repeat again. AE equals to ED according to what is given us the question. So we actually proved that those two right triangles can join to each other according to angle side angle rule. We have those two angles inside AE in the green triangle can join to those two angles and the side ED on triangle PED. So I write it down. So triangle the green right triangle, triangle ABE, is congruent. This is the sign of congruent to the right triangle, triangle PED, according to angle side angle rule. I repeat again. The green right triangle, triangle ABE, congruent to the right triangle, triangle PED, according to angle side angle rule. So what is angle side angle rule? Angle side angle rule states that if two angles and the side that included between those two angles. In one triangle. Congruent correspondingly to two angles and the side that included in another triangle then the triangles congruent to each other according to angle side angle rule. So I'll repeat on angle side angle rule again. Angle side angle rule states that if two angles and the side that included between those two angles in one triangle congruent correspondingly to two angles and the side that included in another triangle, then the triangles congruent to each other according to angle side angle rule. And in our those two triangles, we proved that those two angles and the side that included between those two angles, that is to say side AE, in the green triangle, congruent to those two angles and the side that included between those two angles, that is to say side ED, in triangle PED. Therefore, we proved that those two triangles congruent to each other according to angle side angle rule. Okay? And from the fact that those two triangles congruent to each other, we will conclude that BE equals to EP. Okay, BE equals to EP. BE equals to EP according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides BE and EP will be equal to each other. So BE equals to EP, but we have already know it is given us in the question that BE equals to 7 units. BE equals to 7 units. So we can write here that BE equals to 7 units. It is given us in the question. From this equality, we will conclude that EP also equals to 7 units. Okay, EP equals also to 7 units. So we can write here that EP equals to 7 units. In the next step, we will define the area of quadrilateral, the green quadrilateral EBFD SY. That is to say, the area of quadrilateral EBFD the brackets is the sign for the area. It means the area of triangle EBFD is equal to y according to our definition. Okay, and we will also define the area of the green right triangle, triangle ABE is x. So the area of the green right triangle, triangle ABE, again, this is the side of the area. It means the area of triangle ABE equals to x according to our definition. So actually the area of the green shape that we are looking for equals to x plus y. The area of the green shape is equal to x plus y. You can easily see it from the drawing. The area of the green shape equals to x plus y. Okay, and because of the fact that those two triangles can congruent to each other, they also have the same areas. So if the area of the green right triangle, triangle ABE equals to x units, to x square units, then the area of triangle PED will be also equal to x square units. Because of the fact that they can go into each other, they have also the same areas. And if we focus on triangle PBF, you can see that the area of triangle PBF is equal to x plus y. The area of triangle PBF is equal to x plus y, exactly the same area of the green shape, that is also x plus y. So we can find out the area of triangle PBF, and in this way we will find out the area of the green shape. Okay? And we know that this triangle PBF is an isosceles triangle. Why? Because it has two angles that are equal to each other. They are both equal to theta. So we can write down that the area of triangle PBF, that's triangle PBF is an isosceles triangle because of the fact that it has two angles that are equal to each other. They are both equal to theta, so triangle PBF is an isosceles triangle. And we have rule number 3 that relates to an isosceles triangle. According to rule number 3, the median to the base of an isosceles triangle is perpendicular to the base. So I will read rule number 3 again. According to rule number 3, the median to the base of an isosceles triangle is perpendicular to the base. So what is the meaning of rule number 3? The meaning of rule number 3 is that if we have an isosceles triangle, triangle ABC, this triangle is an isosceles triangle because it has two angles that are equal to each other. Okay, those two angles that are equal to each other, they are both equal to theta, therefore triangle ABC is an isosceles triangle. And the base of the isosceles triangle, triangle ABC, is BC. And so if we draw median to the base from vertex A, so this is the median to the base BC, and we will define the touching point of this median with the base BC as point O. Then we know that the median in any triangle, and especially in this triangle, bisect, in this way it bisects, in this case it bisects the base BC into two equal parts. That is to say, BO equals to OC, so if BO equals to X, then OC will be also equal to X. So we know that the median, according to its definition, bisects, here it bisects the base BC into two equal parts, but according to rule number 3, it is not only bisects the base into two equal parts, as you can see from this drawing, but it is also perpendicular to the base BC. That is to say, this angle is equal to 90 degrees, and this angle is also equal to 90 degrees according to rule number 3. The median AO to the base of the of the triangle, the isosceles triangle, triangle ABC, is perpendicular to the base. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. So this is the meaning of rule number 3. Okay, so we can implement rule number 3 in our drawing, because in our drawing we have the isosceles triangle, triangle PBF is an isosceles triangle because it has two angles that are equal to each other, and the base of the isosceles triangle, triangle PBF is PB. So the median from vertex F to the base PB, that is to say FE, is the median to the base PB of the isosceles triangle FPB. As you can see, it is the median Why it is the median? Because it bisects the base PB into two equal parts. That is to say, PE equals to EB, PE equals to 7 units, and EB also equals to 7 units. So the median PE bisects the base PB of the isosceles triangle PFB into two equal parts. But according to rule number 3, it is not only bisects the base PB into two equal parts, but it is also perpendicular to the base. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 3. So, if this angle is a right angle, then the green triangle BEF, is a right triangle because it has one angle that equals to 90 degrees. So we will focus on the right triangle BEF, and we will implement the Pythagoras theorem in the right triangle PBF. Okay, on the right triangle PBF, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse in the right triangle PBF is FB or BF because of the fact that FB is in front of the right angle, therefore it is the hypotenuse. So the square of the hypotenuse is FB squared. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to EB squared plus EF squared. I will repeat again. In the right triangle PBF, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is FB. Therefore, the square of the hypotenuse is FB squared, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to EB squared plus EF squared. Okay, but we know that FB, it is given us in the question that FB or BF, it is the same, FB or BF equals to 9 units. It is given us in the question. So if FB equals to 9 units, then FB squared will be equal to 9 squared. 9 squared is 81. And it equals to EB squared. It is given us in the question that EB or BE, it is the same. It equals to 7 units. EB equals to 7 units. Therefore, BE squared will be equal to 7 squared. 7 squared is 49. And EF is the missing variable, so we will leave it as it is. So in conclusion, we found out that according to equation number 1, 81 equals to 49 plus EF squared. We will subtract 49 from this equation number 1, and we will get that (81 minus 49 is 32), and it equals to EF squared. Here we take a root out of this equation number 1, and we will get that EF equals to the square root of 32. But we know that 32 is 16 times 2, so I write it down. And the square root of 16 is 4, so I write it down. So in conclusion, we found out that EF equals to 4 times square root of 2 units. So we can write here that EF equals to 4 times square root of 2 units. Now it is very easy to find out the area of the isosceles triangle, triangle PBF, that is also the area of the green shape. It will be equal to the base of the triangle times the height to the base over 2. So the area of the isosceles triangle, triangle PBF is equal to the base of the triangle times the height to the base over 2. Okay? I will repeat again. The area of the isosceles triangle, triangle PBF equals to the base of the triangle times the height to the base over 2. So the area of the isosceles triangle, triangle PBF, according to equation number 2, is equal to the base of the triangle. The base of the isosceles triangle, triangle PBF is PB, and the height to the base is EF because of the fact that EF creates 90 degrees with the base. The height is EF over 2. So we found out that the area of the isosceles triangle, triangle PBF, that is also the area of the green shape, equals to PB times EF over 2. What is the length of PB? As you can see from the drawing, PB equals to 7 plus 7, that is to say PB equals to 14 units, times the height, that is EF. We already found out that EF equals to 4 times square root of 2 units, over 2. In conclusion, we found out that the area of the isosceles triangle, triangle PBF, that is also the area of the green shape, equals to 14 times 4 times square root of 2 over 2. 14 over 2 is 7, so I'll write it down. So the area of the isosceles triangle, triangle PBF is equal to 7 times 4 times square root of 2. Here 7 times 4 is 28. So the area of the isosceles triangle, triangle PBF, that is also the area of the green shape, is equal either to 28 times square root of 2 units is equal to 28 times square root of 2 square units, because it is the area, or it, in terms of numbers, it equals to 39.6 square units. I repeat again, we found out that the area of the green shape equals either to 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. So we finished with the first method. In the next step, I will present to you how to find out the area of this green shape according to the second method. In the second method, we know that AB is parallel to DC according to the rule that the opposite sides of a rectangle are parallel to each other. But if AB is parallel to DC, then AB will be also parallel to part of DC. That is to say, AB will be parallel to FC. That is part of DC. So we know that AB is parallel to FC, so we can implement rule number 2. According to rule number 2, alternating angles between parallel lines are equal to each other. Those two angles are defined as alternating angles, and they are located between the parallel lines AB and FC, therefore they are equal to each other. That is to say, this angle, that is actually theta plus theta, it is 2 theta equals to this angle. So this angle will be also equal to 2 theta. Okay, this angle will be also equal to 2 theta according to rule number 2, that alternating angles between parallel lines are equal to each other. Those two angles are alternating angles, and they are located between the parallel lines AB and FC, therefore they are equal to each other. So if this angle is 2 theta, this angle will be also equal to 2 theta. And we also know that all the angles inside a rectangle are right angles. That is to say, this angle equals to 90 degrees. This angle also equals to 90 degrees. And this angle, it is also a right angle, that is to say, it equals to 90 degrees. In the next step, we will focus on this green right triangle, triangle ABE. I will draw it again. So in the right triangle, triangle ABE, first of all, we will define AE as x, that is to say, A equals to x according to our definition, and it is given us the question that A equals to ED. So if AE equals to x, then ED will be also equal to x. Very simple. So here we define AE as x. So in this drawing, you can see that sinus theta equals to x over 7, So in the right triangle, triangle AEB, sinus theta equals to x over 7. If we focus on the right lower triangle, triangle BFC, here sinus 2 theta. So here what is the length of BC? We know that the opposite sides in a rectangle are equal to each other. That is to say AD equals to BC. But we have already found out that AD equals to x plus x. That is to say AD equals to 2x. Therefore AD that equals to BC. So it means that BC will be also equal to 2x. So BC equals to 2x. So what is the value of sinus theta in the right triangle, triangle BFC? Sinus theta equals to 2x over 9. Sinus 2 theta equals to 2x over 9. But we actually have the trigonometric identity that states that sinus 2 theta equals to 2 sine theta cosine theta So according to this trigonometric identity, we can substitute sine 2 theta in equation number 2 by 2 sine theta cosine theta. So we'll do it now and we will get that according to equation number 2, sine 2 theta according to this trigonometric identity is 2 sine theta cosine theta. And according to equation number 2, it equals to 2x over 9. But according to equation number 1, sine theta equals to x over 7. So we can substitute sine theta in this equation, equation number 2, by x over 7. We will do it now and we will get that 2 sine theta. So sine theta is x over 7 times cosine theta equals to 2x over 9. Here we have 2x on both sides of equation number 2, so 2x will get cancelled. And what is left from equation number 2 after we cancel 2x? What is left? It is actually cosine theta over 7 equals to 1 over 9. We will multiply this equation, equation number 2, by 7, and we will get that cosine theta equals to 7 over 9. Cosine theta equals to 7 over 9. So I will write it in a new page that cosine theta equals to 7 over 9. What is the meaning of this equation that cosine theta equals to 7 over 9? Actually, if you want to draw this equation, we will get right triangle with angle theta. The hypotenuse will be equal to 9 units. The side that is near angle theta will be equal to 7 units. And the side that is in front of angle theta is missing. So we will define it as S. And according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say S squared plus 7 squared equals to 9 squared. That is to say S squared plus 7 squared is 49, and it equals to 9 squared, that is to say it equals to 81. Here we will subtract 49 from this equation, and we will get that S squared equals to 81 minus 49 is 32. We will take a root out of this equation, and we will get that S equals to the square root of 32. But 32 is 16 times 2, so I'll write it down. It equals to the square root of 16 times 2. And the square root of 16 is 4. So in conclusion, we found out that S equals to 4 times square root of 2 units. So we can write here that S equals to 4 times square root of 2 units. And now actually we can find out the value of sine theta. From this drawing you can see that sinus theta equals to 4 times square root of 2 units over 9. Okay. And according to equation number 1, we know that sine theta equals to x over 7. Sine theta equals to x over 7 according to equation number 1. But we have already found out that sine theta equals to 4 times square root of 2 over 9. So we can substitute sine theta in equation number 1 by 4 times square root of 2 over 9. We'll do it now, and we will get that 4 times square root of 2 over 9 equals to x over 7 according to equation number 1. We will multiply this equation by 7, and we will find out the value of x. Very simple. Okay. So according to equation number 1, x will be equal to 7 times 4 is 28. Times square root of 2 over 9. So we actually found out that x equals to 28 times square root of 2 over 9. Here x equals to 28 times square root of 2 over 9. So we can write here in the drawing that x equals to 28 times square root of 2 over 9. Here also we have x, that it is also equals to 28 times square root of 2 over 9. And AD equals to x plus x, that is to say AD, side AD of rectangle ABCD, equals to 28 plus 28 is 56 times square root of 2 over 9. And here also 2x, it equals to 56 times square root of 2 over 9. And here we will focus on the right green triangle, triangle ABE. You can see here that cosine theta equals to AB over 7. Here in the right triangle, triangle AEB. Cosine theta equals to AB over 7. I'll repeat again. In the right triangle, triangle AEB, cosine theta equals to AB over 7. But we have already found out that cosine theta equals to 7 over 9. Here we've already found out that cosine theta equals to 7 over 9. So we can substitute cosine theta in this equation by 7 over 9. So we'll do it and we will get that 7 over 9 equals to AB over 7. We'll multiply this equation by 7 and we'll get that AB equals to 7 times 7 is 49. So AB equals to 49 over 9. So we can write here that AB equals to 49 over 9. AB equals to 49 over 9, but because of the fact that the opposite sides of a rectangle are equal to each other, it means that AB equals to DC. So DC will be also equal to 49 over 9. DC also equals to 49 over 9. In the next step, we will focus on this right triangle, triangle BFC. So on the right triangle, triangle BFC, cosine 2 theta equals to FC over 9. Again, cosine 2 theta equals to FC over 9. We will multiply this equation by 9 and we'll get that FC equals to 9 times cosine 2 theta. But we have the trigonometric identity that states that cosine 2 theta equals to 2 cosine square theta minus 1. So we can substitute cosine theta in this equation by 2 cosine square theta minus 1 according to this trigonometric identity. So we will do it now and we will get that FC equals to 9 times cosine 2 theta is, according to this trigonometric identity, it equals to 2 times cosine square theta minus 1. But we have already found out that cosine theta equals to 7 over 9. So if cosine theta equals to 7 over 9, then cosine theta will be equal to 7 over 9 square. So we'll substitute cosine theta in this equation by 7 over 9 square. Again, I will repeat again that we'll substitute cosine 2 theta. We'll substitute cosine square theta in this equation by 7 over 9 square. We'll do it now and we'll get that FC equals to 9 times 2, and cosine square theta equals to 7 over 9 square. Minus 1. Minus 1 is minus 81 over 81, so I'll write it down. So in conclusion, we found out that FC equals to 9 times 7 over 9 square minus 81 over 81. Seven over 9 square is equal to 49 over 81, so I'll write it down. We found out that FC equals to 9 times 2, 49 over 81 minus 81. Two times 49 is 98. So I'll write it down. We'll get that FC equals to 9 times 98 minus 81 over 81. Here 98 minus 81 is 17. So FC equals to 9 times 17 over 81. We will divide the numerator and the denominator by 9, and we will get that FC equals to 9 times 9 is 1, so here we left with the numerator only with 17, and in the denominator 81 over 9 is 9. So in conclusion, we found out that FC equals to 17 over 9. FC equals to 17 over 9, so we can write here that FC equals to 17 over 9. And as you can see from the drawing, DF equals to DC minus FC. DC minus FC equals to DF. I'll repeat again. DF equals to DC minus FC. DF equals to DC minus FC. You can see it clearly from the drawing. So we get that DF equals to DC is 49 over 9 minus FC is 17 over 9. So we found out that DF equals to 49 minus 17 is 32 over 9. We found out that DF equals to 32 over 9. So we can write down that DF equals to 32 over 9. Now we have all the sides of trapeze ABDF, so we can easily find out the area of trapeze ABDF. That is also the area of the green shape. So the area of trapeze ABDF, that is also the area of the green shape, will be equal to the sum of the trapeze sides, that is to say it will be equal to AB plus DF times the height, that is AD, over 2. I will repeat again, the area of trapeze ABDF equals to the sum of its sides, that is to say AB plus DF times the height, that is AD, over 2. So the area of the green shape, that is also the area of trapeze ABDF, will be equal to AB, that is 49 over 9, plus DF, that is 32 over 9, times the height AD, that is 56 times square root of 2 over 9, all divided by 2. So we found out that the area of trapeze ABDF, that is also the area of the green shape, equals to this expression. Here 49 plus 32 is 81. So I'll write it down. So the area of the green shape will be equal to, here we have 81 over 9 times 9, times 56 times root of 2, all divided by 2. So we actually found out that the area of the green shape equals to here 81 over 9 times 9 is 81. So 81 over 81 is 1. So this expression will get cancelled. And we're left only with 56 times square root of 2 over 2. 56 over 2 is 28, so I'll write it down. (28) times square root of 2 square units in terms of numbers is 39.6 square units. I will repeat again. We actually found out that the area of trapeze ABDF, that is also the area of the green shape, it equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. So we finished with the second method. So in the next step, I will present how to find out the area of this green shape according to a second method. I repeat again, I will present to you how to find out the area of this green shape according to the first method. In the first method we will do a construction. We will draw perpendicular from point E to BF. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. We will define the touching point between the perpendicular from point E to side BF is point M. And we'll prove, first of all, we know that all the angles inside a rectangle are right angles, so this angle, it is a right angle, it equals to 90 degrees. This angle is also a right angle, that is to say it equals to 90 degrees, and this angle, it is also a right angle, that is to say it equals to 90 degrees. So in the next step, we will prove that those two right angles can go into each other. Okay, so we will prove that triangle AEB, this great right triangle, we will prove that the right triangle AEB is can go into the right green triangle BEF, this green right triangle. So why they can go into each other? First of all, we know that those two angles, they are equal to each other, they are both equal to theta according to what is given us in the question. So angle ABE, this angle, is equal to this angle, angle EBM, and they are both equal to theta according to what is given us the question. I will repeat again. Angle ABE is equal to angle EBM, and they are both equal to theta according to what is given us the question. And we also know that those two angles, they are both right angles, therefore they are equal to each other. That is to say, this angle is angle BAE, and it equals to this angle, angle BMF. And they are both equal to 90 degrees. I will repeat again. Angle BAE equals to angle BMF, and they are both equal to 90 degrees according to what we have already found out. Okay, and those two angles, they are equal to each other according to third angle theorem. That is to say, angle AEB is equal to this angle BEM, according to third angle theorem. I'll repeat again. Angle AEB is equal to angle BEM according to third angle theorem. So what is third angle theorem? Third angle theorem is that if two angles in one triangle congruent to two angles in another triangle, then the first pair of angles must also congruent. And we actually proved that those two angles in the right green triangle, triangle ABE, congruent to those two angles in the right green triangle, triangle EBM. Therefore, the third pair of angles must also congruent. That is to say, angle AEB must be equal to angle BEM. So angle AEB equals to angle EBM, BEM according to third angle theorem. And BE is a common side, that is to say it belongs to both triangles, so we can write down that BE equals to BE is a common side that belongs to both triangles. BE equals to BE is a common side that belongs to both triangles. I'll repeat again. BE equals to BE is a common side that belongs to both triangles. So we actually proved that those two triangles congruent to each other according to angle side angle rule. Okay, I'll write it down. As you can see here, we have side BE and those two angles that, or you can say that those two angles and the side that included between those two angles, that is to say BE, in triangle AEB, are congruent to those two angles, and the side that included between those two angles, that is to say BE, in the right triangle, triangle EMB. Therefore, those two triangles congruent to each other according to angle side angle rule. So I'll write it down. We found out that triangle AEB congruent to triangle BFM according to angle side angle rule. I repeat again. We actually proved that triangle AEB is congruent to triangle BFM according to angle side angle rule. from the fact that those two triangles can go into each other, we will conclude that AB equals to BM. So AB equals to BM according to the rule that corresponding sides in congruent triangles are equal to each other. And if we define AB as y, then BM will be also equal to y. So we define AB as y, and therefore BM will be also equal to y. And you can also conclude that AE equals to EM. AE equals to EM according to the same rule that corresponding sides between parallel triangles are equal to each other. In corresponding sides in congruent triangles, corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding sides, that is to say AE and EM, will be equal to each other. And if we define AE as x, then EM will be also equal to x because of the fact that they are equal to each other. And we also know that AE equals to EM, so if AE equals to x, then EM will be also equal to x. And we know that BF equals to 9 units and BM equals to y. And MF equals to BF minus BM, that is to say MF equals to BM, that is 9, minus BM, that is y, that is to say MF equals to 9 minus y. Okay? And in the next step, we will connect together points E and F by a straight line. And we will prove that those two right triangles can go into each other. Okay? So, first of all, we know that EM equals to ED. So write it down. We'll prove that the right triangle EDF can point to the right triangle EMF, this triangle. So first of all, we know that ED equals to EM equals to X. ED equals to EM equals to X. It equals to X according to our definition. So ED equals to EM equals to X. And we also know that EF is a common side. It is the hypotenuse in both right triangles. So EF equals to EF is a common side that belongs to both triangles. I repeat again. EF equals to EF is a common side that belongs to both triangles. And we know that those two angles are equal to each other, they are both right angles. So we can write down that angle EDF, this angle, is equal to this angle, angle EMF, and both angles, they are equal to 90 degrees, they are right angles. So you can write down that angle EDF equals to angle EMF, and they are both equal to 90 degrees. So by proving those three things, we actually proved that those two triangles can go into each other according to rule number 5. So what is rule number 5? Rule number 5 states that if the hypotenuse and the perpendicular in two right triangles congruent, then the triangles congruent to each other. I'll repeat again on rule number 5. According to rule number 5, if the hypotenuse and the perpendicular in two right triangles congruent, then the triangles congruent to each other. And here we actually proved that the hypotenuse EF and the perpendicular ED in the right triangle, this right triangle, triangle EDF, congruent to the same hypotenuse EF and the perpendicular EM in the right triangle, triangle EMF. Therefore, we proved that those two right triangles congruent to each other according to rule number 5. So you can write it down, the triangle EDF, this right triangle, congruent to triangle EMF, according to rule number 5. I'll repeat again. We actually proved that the right triangle, triangle EDF, congruent to the right triangle, triangle EMF, according to rule number 5, and from the fact that those two right triangles congruent to each other, we will conclude that MF equals to DF. MF equals to DF, according to the rule that corresponding sides of congruent triangles are equal to each other. and because of the fact that MF equals to 9 minus y, you can see here that MF equals to 9 minus y. So from this equality we will conclude that DF also equals to 9 minus y. DF also equals to 9 minus y. So we can write here that DF equals to 9 minus y. And according to the rule that the opposite sides of a rectangle are equal to each other, it means that AB equals to DC. But AB equals to y, so DC will be also equal to y. DC equals to y. DC equals to y. And here, what is the value of FC? You can see from the drawing easily that DC minus DF equals to FC. So I write it down. DC minus DF equals to FC. I repeat again. You can see from the drawing that DC minus DF equals to FC. Here, DC minus DF equals to FC. So that is to say FC equals to DC, that is y, minus DF, that is 9 minus y. Okay, we found out that FC equals to y minus 9 minus y. We will open the brackets on this side of the equation and we will get that FC equals to y minus 9 minus y is plus y. So in conclusion, we found out that FC equals to y plus y is 2y minus 9. FC equals to 2y minus 9. So we can write here that FC equals to 2y minus 9. And the opposite sides of a rectangle are equal to each other, that is to say AD equals to BC. But we know that AD equals to x plus x, that is to say AD equals to 2x, so BC will be also equal to 2x. And we will focus in here. We will implement the Pythagoras theorem on this right triangle, triangle ABE. According to the Pythagoras theorem, in this right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, x squared plus y squared equals to 7 squared. So I write it down. We found out that according to equation number 1, x squared plus y squared equals to 7 squared. 7 squared is 49. So according to equation number 1, x squared plus y squared equals to 49. If we focus on the right triangle, triangle AEB, this is according to the Pythagoras theorem. And if we focus on the right triangle, triangle BFC, according to the Pythagoras theorem, if we focus on this right triangle, triangle BFC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is BF. BF is 9 units according to what is given us in the question. So if bf equals to 9, then bf squared will be equal to 9 squared. 9 squared is 81. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to fc squared plus bc squared. I repeat again, in the right triangle BFC, according to the Pythagoras theorem, the slope of the hypotenuse equals to the sum of the slopes of the perpendiculars. That is to say, 81 equals to fc squared plus bc squared. So, according to equation number 2, 81 equals to fc is equal to 2y minus 9. So, fc squared will be equal to 2y minus 9 squared plus bc equals to 2x. So 2x squared will be equal to 4x squared. So in conclusion, we found out that according to equation number 2, 81 equals to 2y minus 9 squared plus 4x squared. We will open the brackets on this side of equation number 2, and we will get that 81 equals to 2y minus 9 squared is 4y squared plus 81 minus 36y plus 4x squared. Here we have 81 on both sides of equation number 2, so 81 will get cancelled. So 0 equals to 4 is a common factor for 4y squared plus 4x squared. So inside the brackets we will have x squared plus y squared minus 36y. We will add 36y to this equation number 2, and we will get that 36y equals to 4 times x squared plus y squared. According to equation number 1, this equation x squared plus y squared equals to 49. So we can substitute x squared plus y squared in this equation number 2 by 49. We will do it and we will get that 36y equals to 4 times x squared plus y squared according to equation number 1 is 49. So it is 4 times 49. Here we will divide this equation number 2 by 4, and we will get that according to equation number 2, 36y over 4 is 9y, and it equals to 4 over 4 is 1, so we left only with 49. So actually, in conclusion, we found out that according to equation number 2, according to equation number 2, 9y equals to 49. We will divide this equation number 2 by 9, and we will get that y equals, according to equation number 2, y equals to 49 over 9. And according to equation number 1, x squared plus y squared equals to 49. So here we will substitute the value, we will substitute y squared in this equation, equation number 1, by y squared for equation number 2. According to equation number 2, y squared equals to 49 over 9 squared. So we'll do it now and we will get that x squared and y squared according to equation number 2 is 49 over 9 squared, and it equals to 49. So here we'll subtract 49 over 9 squared from this equation, equation number 1, and we will get that x squared equals to 49 is 7 squared plus minus 49 over 9 squared. Here we will use the trigonometric and the algebraic identity that states that a squared minus b squared equals to a plus b times a minus b, and here in our specific question, b squared is 0, a equals to 7, and b equals to 49 over 9. So here we will get that x squared according to equation number 1 equals to a plus b is 7 plus 49 over 9 times a minus b is 7 minus 49 over 9. So we get that x squared equals to, here we will multiply 7 by 9 and then we will divide it by 9 in order to have a common factor with 49 over 9. So we get that 63 plus 49 over 9 times 63 minus 49 over 9. So we got that x squared equals to 63 plus 49 is 112 over 9 times 63 minus 14 is 14. 63 minus 49 is 14 over 9. So we got that x squared equals to, we substitute 112 by 8 times 14. So it is 8 times 14 times 14 over 9 times 9. Here we substitute 8 by 2 times 2 times 2, and we will get that according to equation number 1, 2 times 2 times 2 times 14 times 14 over 9 times 9 equals to x squared. So We got that 2 times 2 times 2 times 14 times 14 over 9 times 9 equals to x squared. We'll take a root out of this equation, equation number 1, and we'll get that x equals to the square root of 2 times 2 times 2 times 14 times 14 over 9 times 9. So here we will get that x equals to the square root of 2 times 2 is 2, the square root of 14 times 14 is 14, and the square root of 9 times 9 is 9, and inside the root we left only with 2. So in conclusion, we found out that x equals to 2 times 14 times square root of 2 over 9. So 2 times 14 is 28. So in conclusion, we found out that x equals to 28 times square root of 2 over 9. And we have already found out that y equals to 49 over 9. Now we can easily find out the area of trapeze ABDF, that is also the area of the green shape. The area of the green shape will be equal to, we know that the area of any trapeze is equal to the sum of its sides, that is to say in this case is AB plus DF. Times the height is AD, the height of trapeze ABDF is AD, divided by 2. I repeat again. The area of trapeze ABDF, that is also the area of the green shape, equals to the sum of its sides, that is to say it equals to AB plus DF, times the height of trapeze ABDF, that is AD, over 2. But we have already found out that AB equals to 49 over 9, and DF is here, AB and DF is 9 minus y. Here AB is y, AB is y, AB is y, as you can see here. DF is 9 minus y. Times AD, that is 2x over 2. So in conclusion, we found out that the area of trapeze ABDF, that is also the area of the green shape, is equal to this expression y plus 9 minus y times 2x over 2. Y minus y is 0. 2 over 2 is 1. So in conclusion, we found out that the area of trapeze ABDF is equal to 9x, and we have already found out that x equals to 28 times square root of 2 over 9, so I'll write it down. X equals to 28 times square root of 2 over 9. 9 over 9 is 1, so 9 will get cancelled, and we found out that the area of the green shape equals to 28 times square root of 2 square units. Or in terms of numbers, it's equals to 39.6 square units. I repeat again, we actually found out that the area of the green shape, according to the third method, the area of the green shape according to the third method equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. So we finished with the third method. Now I'll summarize the lecture. Actually, we wanted to find out the area of this green shape. We found the area of this green shape in 3 different methods. In the third method, in the first method, we made a construction we extended side CD and line segment BE. We extended them by a straight line until they intersect with each other, and we define the intersection point between extended CD and extended BE as point B. And we know that CD is one side of rectangle ABCD, therefore it is absolutely a straight line. And we extended the straight line CD by straight line, so CP will be still a straight line. So CP is a straight line. So here CP or PC, it is the same, it is a straight line. And we have rule number 1. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. So actually, if we focus on this side of the straight line PC at point D, the sum of the angles must be equal to 180 degrees according to rule number 1. So this angle is defined as X plus this angle that is 90 degrees. The sum of those two angles must be equal to 180 degrees according to rule number 1. We subtract 90 degrees from this equation and we got that angle X equals to 90 degrees. So this angle is the right angle, that is to say it equals to 90 degrees. And then, so we know that PC is this one straight line and AB is parallel to DC because the opposite sides of a rectangle are parallel to each other. So if AB is parallel to DC, then AB will be parallel to the same straight line that is actually PC, because CD and PC lie on the same straight line. Therefore, if AB is parallel to DC, then AB must be also parallel to PC. So we found out that AB is parallel to PC. AB is parallel to PC. And according to rule number 2, alternating angles between parallel lines are equal to each other. So here we have those two angles are defined as alternating angles, and they are located between the parallel lines AB and PC. Therefore, they are equal to each other according to rule number 2. That is to say, angle ABE equals to angle EDP according to rule number 2. But it is given us the question that angle AB equals to theta. Okay, angle ABE equals to theta according to what is given us the question. So from this equation we will derive that angle DPE also equals to theta. So this angle DPE also equals to theta. Then we prove that those two right triangles can join to each other. That is to say, the right green triangle ABE can join to the right triangle PED. Why they can join to each other? First of all, we know that those two angles, we just right now proved that those two angles, they are equal to each other, they are both equal to theta. That is to say, angle ABE equals to angle DP equals to theta. We also know that those two angles, they are both right angles, therefore they are equal to each other. That is to say, angle BAE equals to angle PD equals to 90 degrees. And those two angles, they are vertex angles, and vertex angles are equal to each other. That is to say, angle ABE equals to angle PED, according to the rule that vertex angles are equal to each other. And we have also know that EAE equals to ED, according to what is given us in the question, A equals to ED. So A equals to ED. And actually we proved that those two right triangles can go into each other according to angle side angle rule. While we proved that those two angles and the side that included between those two angles, that is to say AE in the right triangle ABE, can go into those two angles, and the side that included between those two angles, that is to say ED, in the right triangle PED. Therefore we proved that those two angles can go into each other according to angle side angle rule. Okay, so we proved that triangle ABE can go into triangle PED according to angle side angle rule. And what is angle side angle rule? Angle side angle rule is that if two angles and the side that included between those two angles in one triangle can go into correspondingly to two angles and the side that included in another triangle, then the triangles can go into each other according to angle side angle rule. And I'll repeat it shortly. We proved that those two angles and the side that included AE in triangle BAE can go into those two angles, and the side that included, that is to say side ED, in the right triangle, triangle PDE. Therefore we proved that those two right triangles can go into each other according to angle side angle rule. And from the fact that those two triangles can go into each other, we will conclude that BE equals to EP or BE equals to EP. But we know that BE equals to 7 units. It is given us in the question. BE equals to 7 units, so from this equality we will conclude that EP also equals to 7 units. EP equals to 7 units. Then we defined the area of this green quadrilateral EBFD SY. That is to say the area of quadrilateral EBFD equals to Y square units. And we also defined the area of this green right triangle ABE is X. That is to say the area, this is the sign of the area of triangle ABE equals to X according to our definition. Therefore, the area of the green shape equals to X plus Y. You can see from the drawing easily that the area of the green shape equals to X plus Y. And we also know that those two triangles can go into each other. Therefore, they have also the same areas. So if the area of triangle AB equals to X, then the area of triangle PED will be also equal to X. And what is the area of triangle PBF? It is also equal to X plus Y. So the area of triangle PBF equals to X plus Y exactly is the area of the green shape that is also equal to X plus Y. So by finding the area of triangle PBF, we will also find the area of the green shape because they have the same areas. And we know that the triangle ABPBF is an isosceles triangle. This triangle PBF is an isosceles triangle. Why it is an isosceles triangle? Because it has two angles that are equal to each other. Those two angles, they are both equal to theta. Therefore, triangle PBF is an isosceles triangle. And we have rule number 3 that relates to an isosceles triangle. According to rule number 3, the median to the base of an isosceles triangle is perpendicular to the base. What is the meaning of rule number 3? The meaning of rule number 3 is that if we have this triangle ABC is an isosceles triangle. Why? Because it has two angles that are equal to each other. Both those two angles are equal to theta. And we know that the base of the isosceles triangle, in this isosceles triangle ABC is BC. So if from the vertex A we will go median to the base BC, here the touching point of the median from point A to BC, the touching point of the median with the base BC is at point O, and we know that the median bisects the base BC into two equal parts, that is to say BO equals to OC. So if BO equals to X, then OC equals to X. This is the definition of the median, that it bisects the base. But according to rule number 3, the median is not only bisects the base into two equal parts, but it is also perpendicular to the base, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. So we can implement rule number 3 in our drawing, because in our drawing we have the isosceles triangle PBF, and the median FE. Why FE is the median? Because it bisects the base BP into two equal parts. BE equals to EP equals to 7 units. Therefore, if FE is the median, but according to rule number 3, the median FE in an isosceles triangle, it is not only bisects the base BP, but it is also perpendicular to the base BP. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. And because of the fact that this angle equals to 90 degrees, then the green triangle BEF is a right triangle because it has one angle that equals to 90 degrees. So we can implement the Pythagoras theorem and the right triangle BEF. On the right triangle BEF, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is FB, so the square of the hypotenuse is FB squared. It equals to the sum of the squares of the perpendiculars. That is to say, it equals to EB squared plus EF squared. FB equals to 9 units. It is given us in the question. So FB squared is 9 squared. 9 squared is 81. 9 squared is 81. EB equals to 7 units. It is given us in the question. So EB squared will be equal to 7 squared. 7 squared is 49. So in conclusion, we got, according to equation number 1, that 81 equals to 49 plus EF squared. We subtracted 49 from this equation number 1. And we got that 41 minus 81 minus 49 is 32. So in conclusion, we got that 32 equals to EF squared. We took a root out of this equation number 1, and we got that EF is equals to the square root of 32, but 32 is 16 times 2, and the square root of 16 is 4. So in conclusion, we found out that EB equals to 4 times square root of 2 units. So we found out that EF equals to 4 times square root of 2 units. So we can easily now find out the area of the isosceles triangle PBF, because the area of any triangle, and especially the area of triangle PBF, equals to the base of the triangle times the height to the base over 2. The base of triangle PBF, the isosceles triangle PBF, is PB. The height is EF. So the area of the isosceles triangle PBF will be equal to the base PB times the height EF over 2. PB equals to 7 plus 7, and EF equals to 4 times square root of 2. So PBF equals to 14 times 4 times square root of 2 over 2. 14 over 2 is 7. So in conclusion, we found out that the area of the isosceles triangle PBF, that is also the area of the green shape, equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. So we finished with the first method. Then I presented to you how to find out the area of this green shape according to the second method. in the second method, we used rule number 2. We actually know, first of all, that AB is parallel to DC according to the rule that the opposite sides of a rectangle are parallel to each other. But if AB is parallel to DC, AB will be also parallel to the part of DC. That is to say, AB will be also parallel to FC, so we know that AB is parallel to FC, and according to rule number 2, alternating angles between parallel lines are equal to each other. Those two angles are defined as alternating angles, and they are located between the parallel lines AB and FC, therefore they are equal to each other according to rule number 2. That is to say, this angle ABF equals to angle BFC, but this angle BF is 2 theta, and it equals to this angle, so this angle will be also equal to 2 theta. So angle BFC equals to also 2 theta according to rule number 2, and we know that all the angles inside a rectangle are right angles, so this angle, and this angle will be a right angle, Then we focus on this right triangle BAE, and I drew again this right triangle. So this is the right triangle BAE. We defined AE as x, therefore ED will be also equal to x because A equals to ED. So A equals to x according to our definition, B equals to 7 units according to what is given us in the question. This is angle theta, and you can see from the drawing that sinus theta equals to x over 7. And in the right triangle BFC, this lower right triangle BFC, sinus 2 theta equals to here BC over 9, but BC equals to AD according to the rule that the opposite sides of a rectangle are equal to each other, but we know that AD equals to x plus x, that is to say AD equals to 2x, therefore BC will be also equal to 2x. So in conclusion, we found out that sinus 2 theta will be equal to 2x over 9. According to question number 2, sinus 2 theta in the right triangle BFC, sinus 2 theta equals to 2x over 9. But we also have the trigonometric identity that states that sinus 2 theta equals to 2 sine theta cosine theta. So we can substitute sine 2 theta in equation number 2 by 2 sine theta cosine theta. So we did it, and we got that according to equation number 2, 2 sine theta cosine theta equals to 2x over 2x over 9. And according to equation number 1, sinus theta equals to x over 7. So we can substitute sine theta in this equation number 2 by x over 7. We did it, and we got that 2 times sine theta is x over 7 times cosine theta equals to 2x over 9. We have 2x on both sides of equation number 2, so 2x will get cancelled. What is left after we cancel 2x from equation number 2. What is left? It is actually cosine theta over 7 equals to 1 over 9. We multiplied this equation number 2 by 7, and we got that cosine theta equals to 7 over 9. So we found out that cosine theta equals to 7 over 9. So we have what is the meaning of this function that cosine theta equals to 7 over 9? It means that we have a right triangle with hypotenuse that equals to 9 units, and the side that is near angle theta equals to 7 units. The only missing side it is the side that is in front of angle theta, that is to say this side. We define this side as S, and here we know that according to the Pythagoras theorem, S squared plus 7 squared equals to 9 squared. So s squared plus 7 squared is 49, 9 squared is 81. So in conclusion, we found out that s squared plus 49 equals to 81. We subtracted 49 from this equation and we found out that s squared equals to 32. We took a root out of this equation and we got that s equals to the square root of 32. 32 is 16 times 2 and the square root of 16 is 4. So in conclusion, we found out that s equals to 4 times square root of 2 units. Now we can find out the value of sinus theta. Sinus theta equals to 4 times square root of 2 over 9. Sinus theta equals to 4 times square root of 2 over 9. You can see it from the drawing. But according to equation number 1, sinus theta equals to x over 9. So here we can substitute sin theta by 4 times square root of 2 over 9, because sin theta equals to 4 times square root of 2 over 9. So we did it and we got that 4 times square root of 2 over 9 equals to x over 7. According to equation number 1, we multiplied this equation number 1 by 7 in order to get the value of x, and we found out that x equals to 28 times square root of 2 over 9. So we can write here that x equals to 28 times square root of 2 over 9 here also. And if x equals to 28 times square root of 2 over 9, then 2x, that is actually AD, will be equal to 56 times square root of 2 over 9. And BC also equals to AD, so BC will be also equals to 56 times square root of 2 over 9. Okay, so in the right triangle AEB, this right triangle, cosine theta will be equal to AB over 7. Cosine theta equals to AB over 7. But we have already found out that cosine theta equals to 7 over 9, so we can substitute cosine theta by 7 over 9. We did it, and we got that 7 over 9 equals to AB over 7. We multiplied this equation by 7 and we found out that AB equals to 49 over 9. Here AB equals to 49 over 9, but because of the fact that the opposite sides of a rectangle are equal to each other, if AB equals to 49 over 9, then DC will be also equal to 49 over 9. Okay, then what is the value of FC? FC equals to DC minus DF. Okay, here but before that, so we know that cosine 2 theta, before that, cosine 2 theta equals to FC over 9. Cosine 2 theta equals to FC over 9 in the right triangle FCB. I'll repeat again, in the right triangle BFC, cosine 2 theta equals to FC over 9. We multiplied this equation by 9 and we got that FC equals to 9 times cosine theta, 9 times cosine 2 theta. We have the trigonometric identity that cosine 2 theta equals to 2 cosine square theta minus 1. So we can substitute cosine 2 theta in this equation by 2 cosine square theta minus 1. So we did it. And we got that FC equals to 9 times 2 cosine square theta minus 1. But we have already found out that cosine theta equals to 7 over 9. If cosine theta equals to 7 over 9, then cosine square theta will be equal to 7 over 9 square. So we substituted cosine square theta by 7 over 9 square, and we got that FC equals to 9 times 2 times 7 over 9 square minus 1. This is 1. Then 7 over 9 square is 49 over 81. Okay, and then 2 times 49 is 98, so we got this expression. And then we know that 98 minus 81 is 17. So we got that FC equals to 9 times 17 over 81. We divided the numerator and the denominator by 9. 9 over 9 is 1, so in the numerator we left only with 17, and in the denominator 81 over 9 is 9, so in conclusion we found out that FC equals to 17 over 9. Here FC equals to 17 over 9, and what is the value of dF? dF equals to dC minus FC. dF equals to dC minus FC. So dF equals to dC is 49 over 9 and FC is 17 over 9. So in conclusion we found out that dF equals to 32 over 9. dF equals to 32 over 9. So now we have all the sides of trapeze ABDF. That is also the area of the green shape. So we can easily calculate the area of the trapeze ABDF. That is also the area of the green shape. The area of the green shape. So the area of trapeze ABDF equals to the sum of its sides, that is to say AB plus DF times the height AD over 2. AB plus DF, that is the sides, the sum of the sides of trapeze ABDF times the height, that is AD over 2. And we already found out that AB equals to 49 over 9, DF equals to 32 over 9, and AD equals to 56 times square root of 2 over 9, all divided by 2. Here 49 plus 32 is 81, all divided by 9, so it is 9 times 9. 81 over 9 times 9 is also 81. 81 over 81 is 1, so we left only with 56 times square root of 2 over 9. 56 over 2 is 28, so in conclusion we found out that the area of the green shape equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. We finished with the second method. Then I presented to you how to find out the area of this green shape according to a third method. In the third method, we made a construction. Here, from point E, we drew perpendicular to BF. We defined the touching point between the perpendicular from E to BF as point M. So this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, and then we proved that those two right triangles can congruent to each other. Okay, why those two right triangles can congruent to each other? We also know that all the angles inside a rectangle are right angles, so these angles, those angles are right angles. So we proved that the right green triangle AEB can congruent to the right green triangle BFM. Why they can congruent to each other? First of all, we have those two angles, they are equal to each other, they are both equal to theta. So angle ABE equals to angle EBM equals to theta. Those two angles, they are also equal to each other, they are both equal, they are both right angles. So angle BAE equals to angle EBM equals to 90 degrees. And those two angles, they are equal to each other according to third angle theorem. What is third angle theorem? Third angle theorem says that if two angles in one triangle can congruent to two angles in another triangle, then the third pair of angles must also congruent. Okay, we found out that those two angles in the right triangle BAE congruent to those two angles in the right triangle BEM. Therefore, so we have two pairs of angles that can congruent in those triangles. So therefore, the third pair of angles must also congruent. That is to say, those two angles must be equal to each other according to third angle theorem. And we also know that EB equals to EB. EB is the current side that belongs to both triangles. Okay, and therefore we proved that those two right triangles can congruent to each other according to side angle rule. Okay, we have side EB and the two angles in these right triangles congruent to the same side EB, and those two angles in triangle EFM. Therefore, those two triangles congruent to each other according to angle side angle rule. And from the fact that those two triangles congruent to each other, we will conclude that AB equals to BM according to the rule that corresponding sides and congruent triangles are equal to each other. So if AB is Y, then BM will be also equal to Y. And we also will conclude from the fact that those two triangles congruent to each other that AE equals to EM. And if AE is X, then EM is also X. So AB equals to BM equals to Y, and AE equals to EM equals to X. And from the fact that those two triangles congruent to each other, we will conclude that those two equalities are true. Okay, and then, but if BM equals to Y and BF equals to 9, then MF equals to 9 minus Y. And if AE equals to X, then we know that AE equals to ED according to what is given as the question. So ED will be also equal to X. Then we join together points E and F by a straight line and prove that those two right triangles can go into each other. Why those two right triangles can go into each other? We prove the triangle EDF can go into triangle EMF. Why they can go into each other? First of all, ED equals to EM equals to X. ED equals to EM equals to X, according to what we have already proved. We also know that EF equals to EF. EF is a coincide that belongs to both triangles. And those two angles, they are equal to each other. They are both right angles. They are both right angles. So we actually, by proving those three things, we proved that those two right angles can go into each other according to rule number 5. What is rule number 5? Rule number 5 says that if the hypotenuse and the perpendicular in two right triangles congruent, then the triangles can go into each other. And we actually proved that the hypotenuse EF and the perpendicular ED in the right triangle EDF can go into the same hypotenuse EF and the perpendicular EM in the right triangle EMF. Therefore, we proved that those two right triangles can go into each other according to rule number 5. So we proved that triangle EDF can go into triangle EMF according to rule number 5. And from the fact that those two triangles can go into each other, we will conclude that MF equals to DF, MF equals to DF, here MF equals to DF. According to the rule that corresponding sides in congruent triangles are equal to each other. And if MF equals to 9 minus Y, we will conclude that DF also equals to 9 minus Y. And we know that the opposite sides of a rectangle are equal to each other. That is to say, AB equals to DC. So if AB equals to Y, then DC will be also equal to Y. And what is the value of FC? FC equals to DC minus DF. Okay, FC equals to DC minus DF. But we already found out that DF equals to Y and FC equals to 9 minus Y. So FC equals to Y minus 9 minus Y. We open the brackets here and we got that FC equals to Y minus 9 plus Y. That is to say FC equals to 2Y minus 9. So we found out that FC equals to 2Y minus 9. And we know that AD equals to BC. So if AD equals to 2x, then BC also will be equal to 2x, according to the rule that the opposite sides of a rectangle are equal to each other. Then we focus on this right triangle. According to the Pythagoras theorem, x squared plus y squared equals to 7 squared. Okay, here x squared in the right triangle, triangle AEB, x squared plus y squared equals to 7 squared. 7 squared is 49. And in this right triangle, according to the Pythagoras theorem, BF squared, that is 9 squared, is 81, equals to FC squared plus BC squared. Again, 81 equals to FC squared plus BC squared. We have already found out that FC equals to 2y minus 9, so FC squared will be equal to 2y minus 9 squared, plus BC is 2x, so BC squared will be equal to 4x squared. we open the brackets here and we got that 81 equals to 4y squared plus 81 minus 46y plus 4x squared. We have 81 on both sides of the equation number 2, so 81 will be cancelled. And we got that here 0 equals to 4 is a common factor from 4y squared plus 4x squared. So inside the brackets we have x squared plus y squared minus 36y. So we got that we added 36y to this equation number 2, and we got that 36y equals to 4 times x squared plus y squared. X squared plus y squared equals to 49 according to equation number 1, so we can substitute x squared plus y squared from equation number 2 by 49 according to equation number 1, so we did it, and we got that 36y equals to 4 times 49. And then we divided this equation number 2 by 4, and we got that 36 over 4 is 9, so in conclusion we got that 9y equals to, here 4 over 4 is 1, so we left only with 49. So in conclusion we got that 9y equals to 49. We divided this equation number 2 by 9, and we got that y equals to 49 over 9. Then we have equation number 1 that states that x squared plus y squared equals to 49. So we can substitute y squared in this equation number 1 by 49 over 9 squared from equation number 2, because it equals to y squared according to equation number 2. So we did it, and we got that x squared plus y squared is 49 over 9 squared equals to 49. So in conclusion we got that x squared is equals to 49 is 7 squared minus 49 over 9 squared, and we use the algebraic identity that a squared minus b squared equals to a plus b minus b. Here in our specific equation, b squared equals to 0, a equals to 7, b equals to 49 over 9. So here we got that x squared equals to a plus b is 7 plus 49 over 9, and a minus b is 7 minus 49 over 9. So in conclusion we got that x squared equals to, here we multiplied 7 by 9 and then we divided it by 9 in order to have a common factor with 49 over 9. So in conclusion we got that x squared equals to 63 plus 49 over 9 times 63 minus 49 over 9. 63 plus 49 is 112. So we got here 112 over 9, and 63 minus 49 is 14. So here we got 14 over 9. So in conclusion we got that x squared equals to 112 over 9 times 14 over 9. 112 is 8 times 14, so we substituted 112 by 8 times 14. So we got that x squared equals to 8 times 14 over 9 times 9. 8 is 2 times 2 times 2. We substituted 8 by 2 times 2 times 2, and we got that 2 times 2 times 2 times 14 over 9 times 9 equals to x squared. We took a root out of this equation number 1, and we got that x equals to this expression. The square root of 2 times 2 is 2, the square root of 14 times 14 is 14, and the square root of 9 times 9 is 9. And in the root we only left with 2, so in conclusion we got that x equals to 2 times 14 over 9 times square root of 2. 2 times 14 is 28, so in conclusion we got that x equals to 28 times square root of 2 over 9, and we already found out that y equals to 49 over 9. Then we know that the area of any trapeze is equal to the sum of its sides. In this case is the sum of the sides of trapeze ABDF equals to AB plus DF, and the height is AD, all divided by 2. AB equals to y, DF equals to 9 minus y, AD equals to 2x. So we got this expression, and the area of trapeze ABDF, that is also the area of the ring shape, equals to y minus y is 0. So here we left with 9, and 2 over 2 is 9. So in conclusion we got that the area of trapeze ABDF, that is also the area of the ring shape, equals to 9x. And we have already found out that x equals to 28 times square root of 2 over 9. So we put the value of x inside x, and we got here that the area of trapeze ABDF, that is the area of the ring shape, equals to 9 times 28 times root of 2 over 9. 9 over 9 is 1. So we got in the conclusion that the area of the ring shape equals to either 28 times root of 2 square units, or in terms of numbers, it equals to 39.6 square units. Okay, thank you very much.